Hello, welcome back. We're on section 9.2 of the hypothesis testing chapter. And here we're looking at type 1 and type 2 errors. This is fairly simple. It's just a matter of memorizing it. If you look at this table on page 393, you can see here that we have the population condition. So this is what's true. Either H naught is true or the alternative hypothesis is true. And then we have the results of our hypothesis test where we accept H naught or reject H naught. This first condition right here is where H naught is true and we conclude to accept H naught. There we have a correct conclusion. That's what we want. You can see over here, the alternative hypothesis is true and we reject H naught. There we get the correct conclusion. The problem becomes when for example, we reject H naught, but H naught is true in this case. That's a type 1 error. Okay. Or we accept H naught when the alternative is true, and that is what we call a type 2 error. Okay. So here we have a null hypothesis that mu is less than or equal to 24, and an alternative hypothesis, mu is greater than 24. Okay. So in this application, the type 1 error of rejecting H naught when it is true. So for example, we would conclude this with these automobiles that the alternative, we conclude to reject H naught. We never prove anything with hypothesis testing. We always reject or fail to reject our null hypothesis. It's either no good or it's still in play. So here we would reject the null hypothesis. In this case, that mu is less than or equal to 24 gallons. We're saying no, that the actual population mean is more likely greater than 24, when in fact it's still less than or equal to 24. That's some sort of new improvement to the engines. For example, we want to see if it improves fuel mileage. The car's got 24 miles before, put this new part on the engine, and now we're trying to see if we're going to get greater than 24 miles to the gallon. We accept that when it's false, then we could get in trouble with, say, the government, okay, by falsely labeling our cars. The level of significance is the probability of making a type 1 error when the null hypothesis is true as an equality. So here, we're going to use what we call a level of significance to attach a probability of committing that type 1 error of rejecting H naught when it's actually true. Okay. We use a Greek symbol alpha to indicate this level of significance. We pick this on our own. We may have a committee, we may use previous research to see what has been acceptable in the past as a level of significance. There's a number of factors which might lead us to choose some level of significance, and that's the probability of making a type 1 error. We use a Greek symbol alpha, you can see that right here, to denote that level of significance. And there are some common choices. There's 0.1, 0.05, 0.01. So a 10, a 5, or a 1% chance of making a type 1 error. So we are going to control for that. If the cost of making a type 1 error is high, say with these miles per gallon on the cars, if we improperly label the car, we can get sued later. We would want a small value of alpha. Maybe we would use 0.01, a 1% chance. We could go even lower. These are just common choices. If the cost of making a type 1 error is not high, then we might choose larger values for that alpha. Okay, so we're going to scroll down here and look at problem number 5. This is, excuse me, on page 394. Duke Energy reported that the cost of electricity for an efficient home in a particular neighborhood of Cincinnati, Ohio, was 104%. So we're going to hypothesize here that the mean is $104 per month. A researcher believes that the cost of electricity for a comparable neighborhood in Chicago, Illinois is higher. A sample of homes in this Chicago neighborhood will be taken, and the sample mean monthly cost of electricity will be used to test the following null hypothesis. So our null and alternative hypothesis. So our null hypothesis is that mu is less than or equal to $104 in Chicago. And our alternative will be that the mean for a home in Chicago is greater than that $104. So if we assume that the sample data led to the rejection of the null hypothesis, what would be your conclusion about the cost of electricity in the Chicago neighborhood? Here, we would assume that, or conclude, that the price is higher, that it costs more money per month to run an efficient home in Chicago than in Cincinnati. Now, the type 1 error in this situation would be that it's not more expensive to run a home in Chicago than Cincinnati. That's true, but we concluded that it was. That would be a type 1 error. Okay. The consequences, well, are they dire? Here, the answer to that question would probably be there are not high costs to that. Okay. This is a home energy report. We're probably not going to get sued over it. Nobody is probably basing their life finance on whether or not the price of running this home in Chicago is more. So here we might conclude that we should use a higher number, maybe a 0.05 or a 0.1 for our alpha. What is the type 2 error in this situation? The type 2 error in this situation would be if we were to have accepted the null hypothesis. Has accepted the null hypothesis that the price of running a home is no more expensive in Chicago than Cincinnati, when in fact it was true that it is more expensive. So here, again, what are the consequences of making this error? Probably not so much, since this is being done on a home energy report for, it looks like, a magazine or trade journal. So again, we're going to probably go with a higher level of significance. That's it. This is a fairly short section. Thank you and have a great day. Goodbye.